Hi, Chemistry. It is Thursday, October 8th, and today we were learning about acids. Acids are ionic compounds, and we learned how we can name them and we can formulate them. We really just learned about our two-element acids today. So I'm going to flip this screen around and I'm going to show you a few things that we talked about. Okay? First of all, if you see on the whiteboard, we have the pH scale. So let me get my finger up there. Whoa, here's my pH scale. It goes from 0 through 14. Okay? pH stands for the potential for hydrogen ions. That's why it's always a small p and a big H. The pH scale is a logarithmic scale. That means for every change in number, we have a 10-fold increase in the amount of hydrogen ions. So if you look up there, if I went from a 7 down to 6 on the pH scale, at 6, I have 10 times more the amount of hydrogen ions than I did at a 7. If I jumped down to a 5, the difference is 10 times 10, which would be 100 times the difference. That's what a logarithmic scale means. If I go from a 7 all the way down to 4, I have changed 3 positions, but it's a 10-fold change each time. So 10 times 10 times 10 gives me 1,000 times the amount of hydrogen ions. That's what it means to have a logarithmic scale. So on the acidic end, we have from 0 through 6 is the acidic end. That includes our hydrogen ions. The basic and the alkaline side is from 8 up to 14. Most of our strong bases are hydroxides in nature. Okay? So I have nitric acid written up here on the board. This is a polyatomic acid, and we're actually going to talk about those. We'll talk about them today. We'll talk about them after we talk about the two-element acids. Okay? Any acid in water will dissociate. That's a fancy term for meaning they split into the positive and the negative halves. So when I put nitric acid into water, it splits into a hydrogen ion and then a nitrate ion. That is the nitrate ion, NO3. The strength of an acid comes from how easily the hydrogen ions are formed or how easily they dissociate from the negatively charged half of the compound. We'll learn about concentration of acids here in the springtime, but concentration has to do with how much of the chemical was dissolved in water. Concentration and strength in acids does not mean the same thing. So, we talked about, we have some special group of two-element acids. They are formed from a hydrogen ion combined with a halogen. The only 4 halogens that we care about are fluorine, chlorine, bromine, and iodine. Our halogens are in group 17 of the periodic table. There's 2 more elements in that group, but they are astatine, which we're not going to worry about because it's the rarest substance on Earth, so we're not going to create an acid out of it. And there's also tennessine. Tennessine is a radioactive substance that they created in a reactor or particle accelerator. So once again, we are not going to make any acids out of that. So hydrogen has a +1 charge. Fluorine, chlorine, bromine, and iodine are all a -1 charge. Just like any other ionic compound, we can just squeeze their symbols together and we will give them this hydro prefix as we name them. If we have HF, if we were going to name that like a normal ionic compound, we would call it hydrogen fluoride. HCl would be called hydrogen chloride. HBr is called hydrogen bromide, and HI is called hydrogen iodide. It's okay to name them in that manner if we're talking about their solid substance. But as soon as we have dissolved them in water, they become an acid. Then we change their naming system to, as you see here, the two-element acids get the hydro prefix, And we drop the IDE ending and we replace it with an IC, with an ic ending. All acids always begin with an H for hydrogen. And then they always, all the common ones you're going to know about, end with an ic ending. So hydrofluoric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. There's a star next to the hydrochloric acid because we will use it in class. And the other ones we do not have available to us. They're either hydrofluoric is way too dangerous. There's no sense in me having it. I don't think I can even order it. It is the most reactive acid that there is. If I were to spill it on myself, it can eat all the way through my flesh into my bone. I am a very messy person and I don't really want to have that stuff around. Okay? So those are our 4 common acids that are made of 2 elements. Other common acids we're going to deal with are nitric acid. It's a hydrogen hooked to the nitrate group. Okay? We have nitric acid. If you have your study guide handy, you might want to put a little star next to the nitrate group. Okay, acetic acid is also in the -1 column. It is a hydrogen hooked to an acetate group. +1 for the hydrogen, -1 for the acetate group. In these polyatomic acids, there is no hydro prefix. Okay? So a hydrogen with the acetate group we just call acetic acid. We have hydrogen with a sulfate group. It's a sulfuric acid. You notice now we have 2 hydrogens there. The 2 came from the sulfate group. It had a charge of 2-. Hydrogen still has a charge of +1. In the -2 group, we also have carbonic acid. So H2CO3 is carbonic acid. This is the most friendly acid of all. Carbonic acid just decomposes into water and carbon dioxide. It is found in a lot of carbonated beverages. Your sulfuric acid is found in your car batteries, so beware of that. It's a very concentrated, very reactive and strong acid. And our only one we have in the -3 column is the hydrogen hooked with the phosphate group. This one we call phosphoric acid. So those are our common acids that we will use in chemistry. There are more types of acids and they follow different naming rules. But at this point in your chemistry career, you don't really need to know about those. If you take more chemistry in college, then they'll go through more naming rules with you on naming acids. Okay? But we are just going to go with the nitrate group, the acetate group, the sulfate group, the carbonate group, and the phosphate group. And then our 2-element acids that we already talked about. So that's what we did in class today. We talked a whole lot about different acids and where you'll find them and pHs of different things. But that's the main portion that you need to know for today. Your hydrochloric acid is your stomach acid. We talked about stomach acid a whole lot in class today. Maybe got on a side tangents of what happens when you've been throwing up a lot and how that can degrade your esophagus because of all of the stomach acid. That's just a little sidebar connection to biology and anatomy there for you. Okay. Anyway, tomorrow we're going to do a few demonstrations with acid. We will make a video of it for you so that you can see that. But for today, you should have a few notes that you could have jotted down of all of those common acids. All right, take care, you guys, and check in tomorrow.